Hey there, welcome to this Lab 8 supplemental video. I'm now using a brand new mic here, so hopefully my audio quality is a little bit better than it has been in other videos. All right, so this video, what I wanted to do is I want to show you guys a little bit about some of the filtering that we've been doing in this lab and how we can use that with audio sources and how we can actually hear that in real time. So I have hooked up a little bit of a complicated setup here, but I'll explain what's going on. So this program that I have over in this window, this is called LabVIEW. So LabVIEW basically allows you to program or write procedures for the MIDAC, which is what I've been using for all my at-home lab stuff. So this is able to specify a bunch of different steps that I want the MIDAC to take, and it's also able to create an interface between my computer and the MIDAC. So first step here is acquiring sound. That's going to record a quick 5-second audio clip from my microphone. Scaling and mapping, that's just going to scale the audio up. Then we're going to pass that audio into this thing called the DAC Assistant. What that is going to do is that's just going to write that audio out as a voltage waveform, as a voltage signal to one of our analog outputs. At the same time, DAC Assistant 2 is going to be reading from a different analog input, right? So we'll be able to read some information about that signal that we just generated. Then we're going to take that output, pass it out to our waveform graph, which is over here. And then we'll also play that audio out loud so we can hear it and save it to a file. Okay? And we can control that all from this window, which is nice because this lets us select the path to output to and see our audio waveform. All right, so now let me show you the very simple circuit that I'm using for this first trial. All right, super simple circuit here, just a single resistor, and you can see we're actually writing and reading the same voltage here. So we're just reading the voltage that's going across this resistor, which is exactly the same voltage that we are generating in the first place. So all that's happening here is we're writing out and we're reading a signal back, and then we're going to play it. This circuit is really just to give you an idea, sort of a control, to give you an idea of what the MIDAC sounds like, because it doesn't sound as good as my mic. So let's go ahead and run this. So this is recording audio for the MIDAC. Now you can see it's passing that on to the next stages here, writing it out and reading at the same time, and should generate audio in a second. Is recording audio for the MIDAC. All right, so you can see it's not the greatest quality there, but you should be able to hear that, you should be able to see that we are able to output and re-record audio there. Great, so now I want to do something with filtering. Let's set up a very simple low-pass filter and see how that affects the audio source. So let me switch back to this camera. Okay, so to make this a low-pass filter, all we're going to do, take out these wires. We're going to add a capacitor in series, just like we did in other parts of this lab. Okay. And just like before, oh, and we need to make sure to hook up our ground again. Sorry if that gets a little blurry. Okay. Great. And now we want to make sure that we only read the voltage across the capacitor. Oh, and I accidentally unplugged the output. Okay, so now you can see our output is this top line here, which is going to output the audio clip as a voltage into this resistor. Then we're going to read the voltage across this capacitor so that it will act as a low-pass filter. And we will play back our low-pass filtered audio. Okay, and I'm actually going to change the file that I'm writing to so that I have a record of both of those. Okay, so let's give this a shot. This audio is for the low-pass filter circuit. Okay, Okay, it's going to process all of that audio and should play it back for us in just a second here. Takes a while.
Audio is for the low pass filter circuit.
Okay, great. So hopefully you could see a little bit of a difference there. And if not, give me 1 second. I'm going to play back both one after another so you can hear the difference. All right, so now I want to play the audios back to back so you can directly hear the difference. So first up is our original.
This is recording audio for the MIDAC. Audio is for the low pass filter circuit.
So hopefully you can see a little bit of a difference between those two clips. So when we had our low pass filter audio, you can hear it sounds a little flatter and some of the higher tones are taken out of that. So this is a really, really basic audio effect that we can do. And, things like electric guitar amplifiers or electric keyboards, they all use just complex combinations of these circuits that we're doing here. This is a simple tone modification. If you've ever seen the treble knob on an amp or even on your radio, what we just did is we just turned the treble way down. So we have less of those higher tones. Okay, so what about a high pass filter? What if we want to take out the low tones? So, pretty easy way to do that. As we saw in the lab, we can take our capacitor and turn it into a high pass filter as long as we just reorder things. So, in order to do this, let me refer back to this camera. Okay. All right, so basically we just have to flip our resistor and our capacitor. So take out the capacitor. Now we're putting the capacitor on the top and our resistor on the bottom. Sorry, this is tough to do one-handed. I'm holding the camera with my other hand. All right, and now we want to make sure that we are just reading the signal across the resistor. So now we have made a low or a high pass filter, and you may want to refer back to the stuff that you did earlier in this lab. I believe it's experiment 3. That shows how we can turn this very quickly and easily into a high pass filter like this. All right, so let's see what that sounds like. All right, so first let's switch over to another file to save. Oh, that didn't seem to select the file. We want high pass filter.wave. That is, maybe that's the right file. I hope so. Because otherwise we'll end up rewriting it. It's very possible it's just not going to display the longer path. So high pass filter.wave is what I'm selecting. Yeah, I guess the dots there just indicate it's a long name, so it doesn't want to display it. So this is going to be our high pass filter. So we're only going to hear our lower tones. This is now recording audio for our high pass filter. Sorry, I meant low. Wait, this is a high pass filter. High pass. Is now recording audio for our high pass filter. All right, so hopefully you noticed a little bit of a difference, and we can look at our waveform here. There's not much to see, but it is a significantly higher frequency waves that we are seeing there. Now, let me also play that audio in quick succession with the other one so we can get an example of what that sounds like. All right, so now let's run through all of our audio clips again. I'll play the original, and then the low pass filtered, and then the high pass filtered that we just made. This is recording audio for the MIDAC.
Audio is for the low pass filter circuit.
Is now recording audio for our high pass filter. So hopefully, I hope you guys can hear some of those differences. So one of the things that sounds like there in the high pass filter is it kind of sounds like we just turned down the bass knob or turned way up our treble knob. right? We have a lot of the high frequencies and not quite so many low frequencies, right? So now the last thing that we can do here is, what if we do a bandpass filter? So for my bandpass filter, I'm actually going to make it out of 2 capacitors because I don't have any inductors to use. So I will make sure to select some bands that will be interesting for us. All right, so now our circuit has gotten a little bit more complicated. Let's take a look at this. So what we have here, it's all pretty scrunched up into one place. But we first have a capacitor. That small blue guy is a small capacitor. Then the signal is going to go over both a resistor and another capacitor in parallel with each other. Okay, so this is acting as a bandpass filter. We are effectively able to, perform a bandpass operation with only our 2 capacitors and no inductors, which makes it nice because inductors are far less common in the real world. Now you can also see that we are writing with this red line at the top that's going to go across the first capacitor, and then we are going to be reading with this other red line, which is reading from the line that's in parallel with our second capacitor and our resistor, which will be the bandpass filtered line. All right, so let's go ahead and record that, see what that audio sounds like. This audio is for the bandpass filter. All right, and now we get to wait for it to go through this whole process. Should be ready in just a second. This audio is for the bandpass filter. All right, great. And I did just realize that I forgot to change the path, so that did overwrite our high-pass filtered audio, but we can still compare that to the original and our low-pass filtered. So here's the original. This is recording audio for the MIDAC.
Audio is for the low-pass filter circuit.
Bandpass attempt of the bandpass filter. This audio is for the bandpass filter. Sorry, something sounded off with that audio at first, so I just played it again. But, so you can notice a couple things there. So the bandpass filtered audio seems much more squeezed. We don't have that range of tones. We don't have the high notes. We don't have the low notes. And the bandpass audio is actually a lot quieter. So that's going to be because just the nature of these filters, if we're filtering out more signals, we're inherently losing some of that volume. If we're removing more and more of our audio, there's less audio to play and we lose some more audio, especially if we have a really narrow band that doesn't necessarily match with the frequency of my voice or the frequency of that audio clip. All right, so I hope this was helpful for you guys. And this is just a good demonstration of some of the capabilities of these filters and how we might use them in the real world if we're making some very, very basic audio filter and audio effects. Great. Let me know if you have any questions.